Seg-TTO, test time optimization for domain-adaptive open vocabulary segmentation. Have you seen these three animals? Can you recognize which one is an okapi? What if I tell you okapi is an animal which has striped hind legs, slender giraffe-like neck, large upright ears, and velvety dark coat? With those visual attributes in mind, you might have recognized the third image as an image of an okapi. So, in our approach, we are trying to incorporate these attributes alongside with the unknown class names to push the model vocabulary to an open vocabulary at test time. We use visual feature aggregation techniques to improve our model's vision capabilities. Let's consider that image of the okapi. In our method, we split the input image into random-sized crops. The intuition behind this is to select good crops that can be easily identifiable by the model, whether the object class is present in it or not. Like this one. We use clip encoders to take those probabilities and keep the good crops with a clear gap between the two probabilities, then discard the bad crops. For the selected crops, we tune their embedding at test time to increase the gap between the two probabilities, using an entropy minimization technique with a custom entropy loss function. Then we replace the original image patch with the selected tuned crops. With the aggregated visual features, the new image is fed to the segmentation pipeline. Let's dive deeper into how we do test time feature optimization in our approach. We use OpenAI Clip's vision encoder and text encoder to generate embeddings. Then we take similarity among them and feed those similarities into a selector module. At the selector module, they are sorted from low entropy to high entropy. And after that, we select the ones with the lowest entropies and tune them to minimize their entropy even further. For that, we use a custom self-supervised entropy loss function. Let's take a look at the complete architecture of our project. Here you can see our three main contributions: category attribute aggregation, visual feature aggregation, and test time optimization. Combining all three, we propose the novel test time optimization pipeline for open vocabulary segmentation tasks. We evaluated our model on MES benchmark, which consists of 22 datasets across 5 completely different domains. We have outperformed the current state-of-the-art model and achieved up to 27% increase in some datasets with a 7% overall increase in mean intersection over union performance. Now let's see some of the qualitative samples of our approach. You can see images from various domains, including X-ray images, paintings, human portraits, street views, aerial views, landscapes, underwater images, and many more. For additional results, source code, and further details, please visit our project via the QR code below.